Hello, welcome to video number 53. Is it right? What a question, man. It's kind of steamy. Well, we're talking about right triangles, so it's not that steamy. We want to be able to tell for sure, actually, without even a picture, that triangle is a right triangle or not. This one certainly looks like a right triangle. Angle B looks like a right angle. We could measure it, or we can use slope to tell for sure. So we're going to use slope. Okay, so we're going to find the slope of the three sides of the triangle. Okay, so first let's find the slope of AB. Okay, so as I go over, I go 1, 2, 3, 4, 5, 6 over, and 1, 2, 3, 4 up. So the slope of segment AB is 4 over 6, which is rise over the run, and that simplifies to 2/3. The slope of BC, okay, let's see about that. So we go to the right, and then we go kind of down. So to the right 4 and down 1, 2, 3, 4, 5. So our rise is negative and the run is positive. So slope is negative 5/4. All right, let's check out slope between A and C. So between A and C, we go up quite a ways and then we go over. So we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 2. So the slope is 9/2, which simplifies to, actually that is simplified. So 1, 2, 3, 4, 5, 6. Oh, I messed up. Yeah, that's right, 6. And then up 4. I'm just double checking here. Over 4 and down 5. And then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then over 2. Okay, I'm just double checking. Did it right. Now, we're looking at any of these opposite reciprocals. In fact, we thought this one was a right angle. That's why I was kind of surprised. I thought that was a right angle, but it looks can be a little bit deceiving. It's not quite a 90-degree angle. The reason why I know it is because the slope of BC is negative 5/4, and the slope of AB is 2/3. Those aren't quite opposite reciprocals. They're close, but not quite. That's why it kind of looks like a right angle, but it isn't. So actually, we were full. This one's not a right triangle. That's probably like a little bit less than 90 degrees. Okay, so the main idea is that if we find two sides that have slopes that are opposite reciprocals, then those sides are perpendicular. Okay, so that's the secret. Okay, let's try another one. This one clearly isn't a right triangle. The last one was close. In fact, had me really kind of wondering. Let's do this one though, just to check. So let's find the slopes. So we're going to find the slope of DE. So we went down and to the right. So the slope of DE is equal to negative 3 over 4. Okay, the slope of EF. Slope of EF, let's see, we go over 1, 2, 3, 4, 5, 6. We go up 1, 2, 3, 4. So that's 4/6, which is 2/3. And again, let's find the slope of DF. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over and 1 up. And again, we see that none of these are opposite reciprocals. So that means none of the sides meet at a right angle. None of them are perpendicular. So this is not a right triangle like we thought. So our first two examples are not right triangles. All right, let's try this one. Is this one a right triangle? This time we have no picture. And that's why slope is powerful, is I may not be given a graph, but just based on the coordinates, we can see if any of the two sides make a right angle. So we got to find the slope between all the different sides. Okay, so we have to find the slope between R and S. So that's these two. Okay, so it'll be 20 minus 4 over 24 minus 16, which is 16 over 8, which is 2. Then find the slope between S and T. And between S and T, these two, the 7 minus 20 is negative 13, and 10 minus 24 is negative 14, which is just 13 over 14. And finally, the slope between R and T. So, okay, R and T, the first one and last one. 7 minus 4 is 3. And 10 minus 16 is negative 6. That's negative 1/2. So these are the slopes of the sides. Now, we can look at these and tell if any of the two sides are perpendicular. It turns out that that one and this one are opposite reciprocals. So I'm going to abbreviate. So therefore, side RS is perpendicular to this side, RT. We're computing the slope between R and T, and so the slope of that segment is negative 1/2, and that's why that's perpendicular to that side. So kind of interesting. We're going blind. We're just checking the slope of the three sides, and if any two of them are opposite reciprocals, those sides make a right angle. So yes, this one's a right triangle. So that's how we do that. Okay, one more example. So we have a triangle XYZ. Is it a right triangle? I have no idea. So let's find out. So let's find the slope between each pair of vertices. So between X and Z, or X and Y, that's one side, XY. Another side will be X and Z. And the last side will be X and Z. If it helps, make a little sketch. I mean, I don't know if it's right triangle or not. So a sketch really is not accurate, but at least helps me visualize and find the slopes of these three sides. Okay, so X and Y. 4 minus 8 is negative 4 over 10 minus 2 is 8. That's negative 1/2. First one. Second one, X and Z. So 6 minus 8 is negative 2. 4 minus 2 is 2. So that has slope negative 1. And let me see, we did X and Y. I just did X and Z. We need Y and Z. Okay, so Y and Z. That's the pair we don't have. So Y and Z, 6 minus 4 is 2. And 4 minus 10 is negative 6, so it's negative 1/3. None of these are opposite reciprocals, so this is not a right triangle. Or simply no. All right, time for the big event. Here's a journal assignment. So we got some goofy triangle. We have the three vertices. So if it helps, like I said, it's always a good kind of problem-solving strategy to make a sketch so we keep clear what's going on. I have no idea what it looks like, but conceptually we have some triangle and we know the coordinates of the three vertices, and we're checking the slopes of those sides to see if any of them are opposite reciprocals. So this breaks it down for you. Find the slope between A and B, B and C, A and C, then if any of them are opposite reciprocals, then it's a right triangle. All right, good luck. See you in class.